I will repeat my apology that, okay, I usually have all these prepared in advance, but as you know, I became a travel agent in the last fortnight, so my time after hours it's consumed trying to bring people actually here from the most absurd places surrounding Wellington. So the bullet points were this, and the concept of distributed heterogeneous computing, always in the big picture of my original talk about agri-tech, so how can we bring that big computation into where actually the data is produced massively, and then compute it there. So making it small, cheap, fast, secure, scalable, that's classic management comments. The point of security and trust that compute and the challenges of networks, now I see Karen, she could be here as well. And I heard that when every device became a data center. The first time that I heard that expression was from this guy who founded a green company called NVIDIA. So Jensen started to push his comments about, okay, everything needs to be computed on site, and I think that's the Jetson architecture that is trying to use that. I cannot claim that I know what I'm saying exactly, but then a couple of colleagues here, Duncan, Paul, contributed with some comments that I cut and paste and edited. And I'm sorry that you need to read it in this way. The other panelists receive it just an hour before you, so that makes things exciting. So I will just read it slowly, but thanks to advance in hardware processing power and both energy and hardware cost now, relatively cheaper to process data near its source rather than transport. And the whole point here is that, okay, that's the concept of edge. That's the trend of the last few years. And the central processing facility, it's either a data center or even the cloud. So you need to consider that central processing facility as the cloud itself. So meanwhile, network management paradigms continue to evolve towards automated, relatively light human touch, and therefore lower cost and more reliable architectures. You can use machine learning in order to redistribute the knowledge, the information, and in some ways what you want to mention in your car was trying to get the best of the grid. What are the likely future trajectories of the trade-off between distributed data processing with lower transport requirements and cost, and centralized data processing with relatively higher transport requirement and cost? And there is a question how that relates to different geographies. I mean, in New Zealand, we have, I don't know, 85% of renewable energy, and people who work in data centers know that we have a competitive advantage that we can leverage even to other countries. So there is only 5 million people living in New Zealand. Why would a hyperscaler base itself here? However, there are other competitive advantages. And there are a number of questions here that I will go a little bit faster. Can we get exascale results with petascale cost and environmental impact? It's not just the heat, but what about the communications? This is obviously not a teenager's question. Back to the 70s, focus on software efficiency. And I always repeat, do you remember when we sent a man to the moon? Those pieces of hardware, those were the good days when people wrote code only to make things happen, not just in case that everything would happen. Exascale to the edge might suggest pushing the computational burden to smartphones and similar devices. I mean, everyone looks at the smartphones, but I'm trying to convey that other devices which are even lighter. But still, we have the power bottleneck, and essentially there are more things on that topic, but I want to highlight this, which is interesting. How to ensure that data locality laws are also respected. If one leaves a country carrying a smartphone containing data that must remain in that country, is that a violation? And if so, how is it to be enforced? And how does one know that smartphone actually contains such data? And there are two sides here, the ethics and the technology. So let's focus a little bit on the technology, and the ethics is an open discussion. And then to what extent are the results of client-device computation trusted, given that such devices might well have been compromised? The example here is try to spoof SETI at home. I mean, SETI, for the younger people, is search for extraterrestrial intelligence at home, meaning by pooling. I think that they try to do it with the Sega or the Nintendos or the PlayStations. But the word spoofing came into my attention when I started to think into the distributed computing for the agri-tech. So I can bankrupt my neighbor just by spoofing their sensors and, I don't know, making the herd jump to a cliff or run in circles. I just program a drone that tells them to do that. So those are things that are feasible. Not good, but feasible. All right. So, oh, you are smiling.
Smiling.
Frown. Don't look at me, guys.
Where do you want me to start?
Wherever you want. This is a free country.
Okay, so let's start from the heterogeneity angle. I mean, we know that, so I think the edge brings in a huge opportunity to really take advantage of heterogeneity that the data center doesn't, right? Let's be perfectly honest. Data centers today are not heterogeneous. Even when people say they have heterogeneous compute, like accelerated compute, there's no heterogeneity. All the compute runs on the GPU. The CPU is just there to do the housekeeping. And so effectively, you're all running on the same computing element, which happens to be the GPU, right? So there hasn't been any financial or incentive or programming incentive to really put in heterogeneity inside a data center compute. Now, when you're moving compute to the edge, and completely agree the fact that, to do data reduction and there's some intelligence at the edge, then the equation completely changes, because now you're doing one job. You're doing vision, you're doing, whatever you're doing AI at the edge. You can make a lot more of the same arguments that created heterogeneity in your cell phone and your other mobile devices, because now you know exactly what you got to do, you know the economics of that. The programming environment and programming ecosystem is a little more captive, so you can force, unhealthy programming practices that people do in cell phones today, but not to a very broad base. So I think there's a great opportunity now to really push heterogeneity to these edge devices that I think it's new, and it wasn't there before, and that's where I really see some of these technology becoming real.
Maybe I can add to that. I can confirm, I think the same development and what I think that is going also to happen. What I also think that the edge can be also used to perform part of the computation of the accelerators and facilitate easier implementation of this heterogeneity that we want to achieve that today is, I think, not achievable. This is the first thing, so achieving hyperheterogeneity where parts of the preparational steps, data cleaning, anonymization, whatever is done before data reaches the data center. Apart from that, I think that Edge can perform data processing steps to achieve certain level of security and privacy that cannot be achieved otherwise. So if I don't know, collect data at a traffic light or in a smart city, I can immediately replace personal data in terms of some symbols. I want to count how many pedestrians are in the city, so I replace the faces or images just with integers, with numbers, women, female, male, kids, pets, whatever. So this is something where you need this context information to process the data, and then you have this aggregated, anonymized data that can be used in the next step. So I think in this ecosystem, the role of edge computing is, to me, quite clear, how to help to facilitate transition in this hyperheterogeneity and exascale.
I would ask Doug or Jim to comment that you guys have been working what I would call maybe provocative traditional computing, in terms that you have been into what everyone assumes that it's big compute, a big collection of boxes in a big building, and then everything goes into the process there, and then magic happens. Do you feel threatened?
I think one of the things that I think of when I talk about when you talk about exascale to the edge is you take the results of simulations on exascale class machines, large physical simulations, and that might be used to train models that you would you would implement as in inference engines that are running on the edge. And one of the reasons you do that is because what else is at the edge? Well, maybe you have sensors, maybe you have measurement and observation devices, and you would like the results of a large supercomputer simulation to inform the collection of measurement and observation data out at the edge. So I envision, again, I showed a slide in my talk, at the end of my talk yesterday, that showed the E3SM climate simulation, and then coupling to the atmospheric radiation measurement user facility. That instrumentation to collect atmospheric data may have edge computing devices that are trained, again, by the large simulation, but they may have instrumentation that is steered based on what's going on, what is being measured. So there's another aspect of latency when we talk about computing at the edge, because you want decisions to be made in low latency time frames. You want to do real-time control of instruments.
There are a series of workshops or birds of a feather in SC called urgent computing.
Right.
And adjective means precisely that. And we are exposed into that these days of cyclones or earthquakes. So I have my model, my simulation, whatever complexity, on your big collection of boxes. However, things are happening, and it's not that I don't have enough time to bring the latency. What happens if the communications are actually not working as expected? So we also can ask our friends from NIWA that we'll be talking a little bit later. So I mentioned the urgent computing because I've been barely exposed to that, but is that something that you have been thinking about in terms of edge? Because by now you realize that I am a little bit skeptic with regards to buzzwords. We had that conversation with digital twins, but we need to name things in one way. The problem with the name is that it means different things for different people. Is edge urgent? Doug. I always give the microphone to the biggest smile.
I don't really know. Let me just speak to a few things ECP is doing. We do have one project that's focused on one of our light sources, the one at SLAC, LCLS, and its upgrade. Tremendous data rates. And the workflow there that makes sense to me is do as much processing at the edge as you can. In this case, about half the data is going to be processed locally. And this is basically samples that are dropped in front of a free electron laser. And it's really kind of a way cool experimental facility. But there's about a quarter of the data that needs to be analyzed and is thrown away. So about a quarter of the data that is not good, about half can be processed. And then the other quarter is sent back to the mothership, in this case NERSC. And so, to me, and that doesn't get to your urgency question, but I think there are a lot of workflows that'll be like that. Do as much as you can locally, and then you really need to take a closer look, send it back to the mothership. And that's what the project's called Exascale. So that's one example of a workflow. A couple of other things I can mention. We've developed this scientific software stack, E4S. So I like to think that there's an E4S light that could sit on the edge. Much like we had Jim mentioned this, right-sized or lightweight kernels back in the day. And so I can imagine you do have a lightweight software stack that is trimmed down. I think Pete back there has done some of this work already. And so what might be running on the edge? Well, surrogates are really, really hard. Karen can tell you that for sure. But you might have a fast-running surrogate on the edge that uses some of our more traditional software stack as well. So those are two thoughts. I know neither one of them got to the urgency, but that's about all I can say here.
Because at the end of the day, you need to have a motive, and as Ivona said earlier, a commercial reason. Why are we going to the edge if we are comfortable sitting in the data center? Yes, please. It should work.
Yeah. Yes, you need a reason to go to the edge. I experience nowadays a lot of companies, especially from Austria, contacting me because they have the urgency. They have to do environmental monitoring. Glaciers are melting in Austria, so they have to monitor all the time, to do preventive actions, to do a lot of things. In farming, climate is changing. They have to do another type of crops and not new plants to use. So one urgent area where I see that edge computing will and has already impact, and also in the commercial area, is sensing, environmental sensing, agriculture, earth science. Yeah. So this is something where I already see a lot of commercial interests and also a willingness to put money into that. So that's not a buzzword anymore. It's not a buzzword.
So I always rely on my good friend Ruud van der Paas to have a contrarian view, particularly because he's not even smiling. So do you have anything to say? Open that wound.
Well, I try not to talk if I don't know what I'm talking about. So having said that, I was...
You will break your own rule.
I know. So I was thinking about some years ago an experience that I had. That was my first experience with IoT. And my daughter had a problem with her foot. So she got this special boot to protect her foot, and then she had to walk. But the problem is when you do that, you start to walk in an unnatural way, and you may end up being worse because of that. So that was for a school project. She got this idea, well, we can use sensors to actually detect the pressure of my foot, and then we have visual feedback on the boot with red and green LED lights to monitor whether I'm walking in the right way, and if I see all green LEDs, I'm walking in the right way. I thought it was a really good idea. And then she even went as far as you could post that on, submit that to a cloud, and then your doctor can actually monitor you in a way. So that was all fine and good. And of course her dad got to do the programming. She came up with the idea, and I tried to make it work. That was an interesting challenge at the time because I'm really into parallel programming models, and there wasn't much for that. It was very flaky. I tried to find out what's your consistency model and what can I assume, and I got really blank stares on those forums, I can tell you, if I got a stare at all. And the biggest problem actually was that those sensors were cheap and highly unreliable. So that made me think of when we talk about computing at the edge, how about, maybe we should change it, how about not computing at the edge? What if something fails? How about fault tolerance in programming models? If you want to do this at scale, you probably want to have something that's easy to teach to students, widespread. You can't have the one-off for every single device out there. And so that's like an open question. How much fault tolerance do you get in those kind of environments? I know if I look at my own little world called OpenMP, there has been an attempt. I wouldn't call it pathetic, but it's not really much more than that. You can detect if there was some failure, and then you can essentially bail out. That was as far as you will go. That's nothing like fault tolerance, and I do think that these programming models should start thinking about that and make the assumption that things will fail. And again, if somebody has time on their hands, please get started now. We need it.
Well, I think that even the engineers in the room can speak about it's at the end of the day an engineering issue. I mean, things you need to compute, or sorry, it's not the right word that I want to use here. You need to factor into your project management schedule that, okay, which is the plan B, the plan C, things will go wrong. Now, how wrong are you? And that's what I always keep asking to any other speaker. I mean, you give me a figure about this is what I achieve, in which conditions, in which benchmark. And at the end of the day, we live in a world of uncertainty, but where are our boundaries? And this is a panel that can go in many ways. I would like to focus on precisely on, let's call it reliability or fault tolerance. One of the questions is the trade-off between battery life. I mean, in a data center, everything is there, right? It's like a city where you have all the services. Now we're moving into the wilderness. How are we going to make our life there?
So, I mean, I think this community, I don't know if it has ignored the cloud or kind of not really looked at it, but you know, if you're programming an application in a cloud today, everything you just said is second nature, right? I mean, you don't assume that things are going to work. You live in a world of eventual consistency, which means, you know, sometimes your state will be consistent, but you don't know. You got things that pop up and down. You know, I bet that people that write application for Google Maps don't assume that every Google Map endpoint is going to be active at any point in time, right? So there is a built-in tolerance of failures because you assume that all the devices connected in your cloud paradigm are going to be intermittent. So I think we probably need to update our views a little bit. I mean, no, you don't use OpenMP to program these things, period, right? I mean, you use, you use data abstractions and you use tools that are already existing and built for this kind of stuff. So, you know, I think we may be a little bit behind, but, you know, honestly, I think the world of IoT and cloud programming behind it is already there, right?
Mm-hmm. Yeah. Can I open to the floor? Is anyone want to comment on what we have been discussing, or not immediately, but yes, Ben, please, microphone.
I guess I would challenge the urgent part, because urgent means to me fast, like it's got to be fast, but it may not be fast. It's really just time dependent on the use case. It may be the use case needs 30 minutes, but transferring the data may take 30 minutes or more. So it's really a time-dependent problem that you have to understand to know where you put your computation so that you don't move data and waste a bunch of time.
I mean, my interpretation of that before, a totally mundane interpretation of urgent. Netflix, I want to watch that movie now. Buffering, downloading, doesn't feel good. Now imagine that lives depend on that, or transactions, or whatever. So, please comment.
So I'll bring up another use case, the smart grid, where you know the fraction of power generation sources in our power grids now includes a larger and larger fraction of wind turbines and photovoltaics. Energy generation sources that can be intermittent, and that larger fraction of distributed energy resources, the DERs that the power grid community uses, or terms it as, means that there can be instabilities induced in the power grid when all of a sudden the wind stops or the cloud comes. And that means then you need to have more localized, at the edge control. The real-time control algorithms and methodologies. That's another use case for edge computing, where decisions need to be made in real time, so that there's an urgency to prevent cascading grid failures. But again, those algorithms and the control strategies, they're probably informed by large-scale modeling and simulation of the power grid. So there's this coupling between the computing that is performed at large scale, and then the real-time embedded computing that is in controllers for the power grid.
Oh, so panels not necessarily need to reach agreement or any conclusion. So it's a debate, it's a conversation, but I always suggest them with something in mind. And essentially there are two things. We don't need to think computation needs to happen monolithically somewhere where it used to happen for decades, namely the data center. But on the other hand, I also want to put on the table all the challenges that exist. It's not that you put micro data centers everywhere and suddenly magic will happen. That's why I was so interested in the photonics communications talk. It was a quantum computing person also invited here, expert on fault tolerance at quantum level, which is probably 28 years ahead in time. So I am not asking the panel to converge into any agreement, but perhaps which is the main advantage and the main difficulty that you can see in the concept of edge computing, and exascale at the edge, whatever it means to you. Let's start with Ruud.
Okay, that took me by surprise. So I'm going to give the consensus for the whole group. I had a bit of a senior moment here, but so I'll be the consensus.
No.
I'm okay with that. I'm not that democratic that
I won't ask the group about it.
do that. I'll bounce the question back. Why do you need consensus? That's not how I mean,
it's your word. I didn't mention.
Does that make you feel sleep better at night, or should
You're
we
so
just
annoying, my friend.
agree to disagree? And I'm kind of somewhat serious about that. It's like I think it's too early to have consensus. There's so much happening. And I just have to think of how I manage it. That's a totally different story, but I think it's just a nice anecdote. How I managed to have a poor IBM employee completely off guard. A couple of supercomputings ago, when we had the show floor, I think it was 2019 probably. IBM was showing the quantum computing, and it was really very impressive, absolutely no doubt about it. Total science fiction. So I walk up to that, and a friend of mine had just told me that if you just point at a machine, it takes 24 hours to get back into a steady state mode. So having said that, I asked the IBM person, I said, when can I expect this in my self-driving car? And it took him a little bit to realize that was just like wishful thinking beyond anything else. And I think that's where we are. When you talk with people that have more understanding of IoT, for example, is such a variety. So if there was anything that I would like to ask for is some sort of standardization has to happen. Because that's always how things work. You start agreeing on something. Like, how do you program those things? Do existing programming models, Andrew probably has it on his laptop right now as we speak, but that will be my big thing. Can you get some sort of standardization?
And from where that standardization will come, because I can open the question about certain areas of industry that brings together a group of associate parties going in one direction, or the national labs that they are pushing a number of things.
You need all of them. You need all of them. Somebody has to build it, actually, and that's. I think that's why I really enjoyed Tina's talk. They actually have to make it work. We have all these nice diagrams on slides, but they have to build it, and that's when the reality comes in. So yes, you need a consortium, but with all parties involved. I've said more than enough.
Someone else? Yes, please, go ahead.
So you ask opportunities and challenges.
Yes.
Let me start with challenges. To me, one of the biggest challenges of the distributed edge world is that the data is going to end up being captive behind some of the large cloud service providers. Because, Yvonne has presented, all the mobility stuff. Google already has all that data of where the cars are moving, how fast they're moving around, but they're not sharing it with you because they use it to push the product. If we all go down that path, to me, this is a gigantic challenge, and we got to figure out a way to, make sure that does not happen. Opportunities, I think there's interesting new business models that are creative and people. So I was chatting this morning with Karen and Jeff, and you should look up, there's a company called Hitbit. What they do is they sell a space heater, 1,500 watts, you need to heat your space if you live someplace cold. As a side effect of heating your space, it mines cryptocurrencies. And in a few months, you recover the cost and then makes money for you. And they say, it's good for you and it's good for them, of course. Now, I don't say that we want to mine cryptocurrency, but maybe we can do something more useful. But the interesting thing is that they don't sell you as a computer. They sell you as a space heater, and you're already using the energy because you need to heat your rooms, and so the energy is already in the equation, right? So I mean, these are to me the creative new ideas. I'm not sure that I want to crypto mining, but something useful. Maybe you can find ways in which you can actually get the end users to pay for the electricity for this stuff because you give them something back, and so just think about not just the technology, but there's innovation in the business models that I think need to happen for these things to work.
Doug, please.
This is an old person comment. So if the next 25 years is like the last 25 years, I mean, that kind of horsepower on the edge is a given. So in 1998, Jim mentioned ASCII Red was 1 teraflop. Okay. What did it cost, Jim?
Oh, what did it cost? I believe it was on the order of $40 million, but I might be mistaken.
Today's currency would be like $1 billion.
Yes, that was what I was going to say.
So $40 million for 1 teraflop. So the MI250 and Frontier, it's a few $1,000s. It's 50 teraflops. And one node is 200 teraflops. To me, that's hard to believe. Okay,
yeah.
So if the next 25 years or maybe less is kind of like the last, we can think about that kind of horsepower. We can do more than think. But right now, Exascale at the edge, we've got to talk back to the mothership and do things appropriate, but then have surrogates or fast-running inference engines, that are maybe informed by, big simulations.
The closing keynote of 2018 or 19 was a guy that you maybe heard about, Mark Seeger. And
Yeah.
and he simply told the story of his past 40 years and pretty much ended emotionally because, things changed so dramatically in his life. Mark Seeger was the CTO for HPC for Intel, and he came here to give his last public talk, so respect. The point is, I remember not the figures, but his emotion. He said, hey, it's the story of my lifetime. Things happen, and orders of magnitude. Someone asked me in somewhere, an interview, what's the most important technology that you witnessed in your lifetime? The internet. And the guy who was a couple of decades younger than me looked at me like, what are you talking about? It's like telling me that water exists. So, yeah, well, it was once upon a time. So, Jim, please.
So I guess when I think about heterogeneous computing and now distributed heterogeneous, I look at all the opportunities that arise, as Ivona described, where out in the data center can be a quantum computer, something that you won't put on the edge.
No.
Maybe, all right, I'll make a bold prediction. We won't see a quantum computer in our smartphone. On the other hand, we might find that there are high temperature qubits that are actually feasible. But what I think we will see is a world where we will have much more heterogeneity, as I was describing earlier yesterday, that we will see energy efficient computing as a requirement that drives much more specialization, but the actual applications that we need to tackle to meet our societal and national needs will be much more diverse than our traditional high-performance computing applications.
Well, in 2017, we had Professor Michelle Simmons, maybe you heard about her, was Australian of the Year in 2018, World Authority in Quantum Computing. She didn't want her presentation to be recorded because everyone, in her words, will take and make a hype of it. Right. And then I didn't have the interviews at the time, but at some stage she told me, I can build you a quantum computer, one. And I didn't understand what she meant. Later, I started to realize that yeah, things need to start in some way. So we are in what? In the days of Pierre and Madame Curie, or what? So it's 5, 10, 50 years ahead? Yes.
I will also to add something on the challenges and opportunities. When thinking about challenges that we have in edge computing, there are some, and I think that the expectations are high, that edge computing is going to solve a lot of problems, especially if we talk about self-driving cars or steering of drones. Mm-hmm. We have a lot of issues with that, and there are limitations, especially in the area of ethics. I think in Europe we won't have self-driving cars for the next 20, 30 years because we have very restrictive laws and we are very conservative in that. So I think there is a long path to go. I cannot remember who mentioned that the challenge are the new fault tolerance mechanisms that we have to develop and new programming models. That's true. And I show you one of these new fault tolerance mechanisms that we have to develop. This is completely different than what we know now, but we are also working on new programming models.
So what are you telling me, that Fortran won't work?
No, unfortunately, I'm sorry to tell you that. No, we are developing, for example, models for code offloading, where you, I mean, what we know now in distributed systems, you transfer data, and data gets executed somewhere on some application or remote application. We take pieces of code from device A to the edge node so that it can be executed on the edge node. So the programming model is called code offloading. This is also something that is very specific to edge computing. So that's, I mean, there are really new programming models, and we are working on that. I didn't present that in my presentation, but you can check our EdgeSys paper 2022. Where I think there are a lot of opportunities is in the realization of hyperheterogeneity, where edge can take a crucial role in the computational steps in the integration of hyperheterogeneity, where you actually extend the capabilities of the data center to the edge of the network and do already some pieces of work that accelerators have to do. So I think this is a huge opportunity. But yeah, it's going to be messy.
Any other comment from the floor before I ask for the closing statement? You don't need to go, all of you, on a closing statement, but if anyone has anything to say, it will be more. Please join me thanking the panel.